Running code on cleanup with the drop trait. The second trait important to the smart pointer pattern is drop, which lets you customize what happens when a value is about to go out of scope. You can provide an implementation for the drop trait on any type, and the code you specify can be used to release resources like files or network connections. We're introducing drop in the context of smart pointers because the functionality of the drop trait is almost always used when implementing a smart pointer. For example, box customizes drop to deallocate the space on the heap that the box points to. In some languages, the programmer must call code to free memory or resources every time they finish using an instance of a smart pointer. If they forget, the system might become overloaded and crash. In Rust, you can specify that a particular bit of code be run whenever a value goes out of scope, and the compiler will insert this code automatically. As a result, you don't need to be careful about placing cleanup code everywhere in a program that an instance of a particular type is finished with. You still won't leak resources. Specify the code to run when a value goes out of scope by implementing the drop trait. The drop trait requires you to implement one method named drop that takes a mutable reference to self. To see when Rust calls drop, let's implement drop with printline statements for now. Listing 1514 shows a custom smart pointer struct whose only custom functionality is that it will print dropping custom smart pointer when the instance goes out of scope. This example demonstrates when Rust runs the drop function. The drop trait is included in the prelude, so we don't need to bring it into scope. We implement the drop trait on custom smart pointer and provide an implementation for the drop method that calls printline. The body of the drop function is where you would place any logic that you wanted to run when an instance of your type goes out of scope. We're printing some text here to demonstrate when Rust will call drop. In main, we create two instances of custom smart pointer and then print custom smart pointers created. At the end of main, our instances of custom smart pointer will go out of scope, and Rust will call the code we put in the drop method, printing our final message. Note that we don't need to call the drop method explicitly. When we run this program, we'll see the following output. Rust automatically called drop for us when our instances went out of scope, calling the code we specified. Variables are dropped in the reverse order of their creation, so D was dropped before C. This example gives you a visual guide to how the drop method works. Usually, you would specify the cleanup code that your type needs to run rather than print a message. Dropping a value early with standard mem drop. Unfortunately, it's not straightforward to disable the automatic drop functionality. Disabling drop isn't usually necessary. The whole point of the drop trait is that it's taken care of automatically. Occasionally, however, you might want to clean up a value early. One example is when using smart pointers that manage locks. You might want to force the drop method that releases the lock to run so other code in the same scope can acquire the lock. Rust doesn't let you call the drop trait's drop method manually. Instead, you have to call the standard mem drop function provided by the standard library if you want to force a value to be dropped before the end of its scope. If we try to call the drop trait's drop method manually by modifying the main function from listing 1514 as shown in listing 1515, we get a compiler error. When we try to compile this code, we'll get this error. This error message states that we're not allowed to explicitly call drop. The error message uses the term destructor, which is the general programming term for a function that cleans up an instance. A destructor is analogous to a constructor, which creates an instance. The drop function in Rust is one particular destructor. Rust doesn't let us call drop explicitly because Rust would still automatically call drop on the value at the end of main. This would be a double free error because Rust would be trying to clean up the same value twice. We can't disable the automatic insertion of drop when a value goes out of scope, and we can't call the drop method explicitly. So if we need to force a value to be cleaned up early, we can use the standard mem drop function. The standard mem drop function is different from the drop method in the drop trait. We call it by passing the value we want to force to be dropped early as an argument. The function is in the prelude, so we can modify main in listing 1515 to call the drop function as shown in listing 1516. Running this code will print the following: custom smart pointer created, dropping custom smart pointer with data, some data, custom smart pointer dropped before the end of main. The text, dropping custom smart pointer with data, some data, is printed between the custom smart pointer created and custom smart pointer dropped before the end of main text, showing that the drop method code is called to drop C at that point. You can use code specified in a drop trait implementation in many ways to make cleanup convenient and safe. For instance, you could use it to create your own memory allocator. With the drop trait and Rust's ownership system, you don't have to remember to clean up because Rust does it automatically. You also don't have to worry about problems resulting from accidentally cleaning up values still in use. The ownership system that makes sure references are always valid also ensures that drop gets called only once when the value is no longer being used. Now that we've examined box and some of the characteristics of smart pointers, let's look at a few other smart pointers defined in the standard library.